Okay, section 4.3, the limit of indeterminate forms and L'Hopital's rule. Okay, L'Hopital's rule. So, yeah, sometimes we have a function of the following form, following indeterminate forms: 0 over 0, infinity over infinity, or 0 times infinity, or 1 to the infinity, etc. Here, in this case, L'Hopital's rule will allow us to determine many of these limits. Here, L'Hopital's rule: let f and g be differential function on an open interval containing a, and g prime is not equal to 0 near a. Okay? Then, limit f of x over g of x when x approaches to a has if this limit has indeterminate form of type 0 over 0 or infinity over infinity, then the limit of f of x over g of x is same as the limit f prime of x over g prime of x when x approaches to a. Okay. If the limit on right side exists. Okay. This result follows immediately from this relationship. F of x of g of x can be written in this way. This can be written in this way. So so from this relationship, we can easily produce the L'Hopital's rule. Okay. Okay. So for the limit of hyperbolic sign, hyperbolic inverse of x over x, then this function can be written in this way. So as you see, if x goes to infinity, then as you see, this goes to 0 over 0. So the first derivative of hyperbolic sign, hyperbolic inverse of hyperbolic sign, the derivative of this can be written in this way. The derivative of x is this, so we can find the limit of this function is 1 by L'Hopital's rule, and limit x times ln of x when x goes to 0 from the right hand side can be written in this way. That makes infinity over infinity. So if you adopt the L'Hopital's rule, then you can show the limit is 0. And 0 times infinity examples, and infinity minus infinities, and these. These are the examples that you have seen from high school years. Only differences are you are dealing with the function such that the hyperbolic functions and some general forms of functions over the simple ones. Okay. And those are the examples of the techniques of using the L'Hopital's rules. Okay. Then, in this case, infinity to 0 power. So this, if x goes to infinity, then this goes to infinity, and 1 over x goes to 0. In this case, let y is equal to limit of x to the 1 over x. Then take a logarithm. Take a logarithm on both sides. Then ln of y is ln of this. Then you can find the limit that you can use the L'Hopital's rule. So use the L'Hopital's rule to get 0 as the limit of this function, which is ln of y. So y can be found e to the 0, which is 1. That's the way of using L'Hopital's rule. So this shows some of the techniques to use L'Hopital's rules. But you can also do the same thing with the computational tools here. For finding the limit of it, then you can you can easily draw the graph of it. Then you can easily find when x goes to 0, then what's the limit of the function? That is 1. So you can determine the limit of this function is 1, and you can also draw the graph of the second function to find the limit when x goes to 0. When x goes to 0, it approaches to 1, if you can draw the graph of it. So these are the things. Now you have a tools to draw the graph, so you can easily make a conjecture of the conclusion. Then you can start the proof of what you get. So for example, if you want to find the limit of this one, you can draw the graph first. When x approaches to 1, what you can expect? If x approaches to 1, then you can find the limit is somewhere here. It's continuous. So now you can use any of the rules that you can apply. So you can expect a lot of things. Here, x times sine 1 over x when x goes to infinity. You can easily draw the graph of it. X sine 1 over x here. Plot what? X times what? Sine 1 over x. 그려볼까? 됐죠? x times sine 1 over x. Okay. X times sine 1 over x. And we don't need this. And we only have P1 here. Then plot. Okay. Here. Control V. Let's see. 가로? 여기? Okay. So you can easily guess when x approaches to certain point, then we can expect what it is. You can magnify this by giving the maximum or minimum value of x in there. And also, you can think what? Something like this, x squared sine 1 of x. Okay, you can even think cube of it. Okay, and you can what? X max is equal to plus 1, and x mean is equal to minus 1. Then you can make what? 0.1. You can magnify it in this way. You can see the behavior of it like this. You can even make a bigger one by magnifying in this way. So you can do many things to look over the behavior of a function at near a certain point. Okay, so those are the things that you can do. So you just try whatever you do, and you share some of the things that you have done through the BBS, and then you submit it at the end of each month. I think that will wrap up the section 4.3, which is the limit, the L'Hopital's rules. And here, for example, at the last problem, let theta be an angle of a sector of a circle. Find this limit P of theta over Q of theta when theta goes to 0 from the right-hand side. Okay, then from here, what is the P theta? The P theta. This is the area. So this is the area of this minus this triangle. So you can easily find the area of P theta, just subtracting this angle from this triangle area from the. And Q of theta is what? This is the area of triangle, so you know the base and height to have this. So you have the limit like this. From here, you see that this is the indeterminate limit. This goes to 0 to 0 over 0. So you do use the L'Hopital's rule, then you will find the limit of this is 0. What this means is the area of this goes to approach to 0 faster than the area of this approaches to 0. That's what it means. Okay? So here L'Hopital's rule has been used in here to show it. So you can do many things with the knowledge that you have covered. And optimization problems, last section of chapter 4. I think that will be enough for today's lecture. Is there any questions?